But of course, you know, I don't know what dialect he speaks. Wuli is not Wuli, Maklay and my Mole. So that's why I tell you, this is really wild. This we can actually kind of disprove from philology, right? Now, in physics, we try to, this book accuses us of being timid or shy or something, but we're reluctant to do this. So there's a Copenhagen interpretation, which David Merman, a friend of mine, actually have extended it somewhat, is that we just think of it, somehow it collapses. It's got to collapse one way or the other. We don't know how, but that's good enough. My colleagues, including me, in it, is that we tend to think of just stop where it gives you the probability. We say, classically, that's what happens. You don't want to know exactly how the coin turns out. Just before the coin turns out, you have the probabilities, you have the information, you're done. Okay, so those are called the informatics approach. And that's, in other words, you make a jump and then you can get on with life. You don't have to think about such a deep. And then there's consistency. That's a very interesting one. That's another friend of mine from the 60s in La Jolla. And it's interesting how we all started thinking about these things. And this is interesting. This is in a really good quantum mechanics textbook by Perez, P-E-R-E-S. I should have written it down. And he says, actually, once you got that many degrees of freedom, so many particles, you get all possibilities very close to each other. So that's why it's like the classical chaos. It's a quantum chaos. So therefore, again, just a little bit of something you don't know, it will go one way or the other. Or it will become chaotic so that you don't actually, you can no longer predict it. And that's good. Then the probability is the same as the coin, right? So it's a metaphysics in any case. Here is saying, well, it's metaphysics. Doing physics, we're fine. We don't have to deal with it. But it's unsatisfactory to philosophers. And I understand that. I sympathize with philosophers. They're taking on much a harder problem. But it's interesting how quantum mechanics brings it out. So here are the 3 points that I wanted to make. One is that, well, the most important characteristic of what is quantum mechanics is that in one state you describe both possibilities of the coin, both up and down. It isn't just up and down or some other orientation. And the technology make use of this for parallel processing. But the measurement is actually always gives you one possibility. I was dwelling on the philosophy or nature of how do we actually get to that one or the other. But that actually kills the quantum mechanics. I did sort of mention that it's not very good to have that. So, but we always have to make a measurement. At the end, how do we know? You know, you're selling me a washing machine. How do you know the clothes is going to be clean or not clean, right? So you have to observe, make a measurement. So, but do it at the end. Do it well designed. It would not wipe away all the advantages of quantum technology. So the connection here is that, you know, this realization of a probability is another way of, to say, the readout problem. It's the classical physics. That's us. We're very big, and we're sentient, and we can observe. We can make machines that observe for us so that we can observe at a little later time. So, and then there's these tiny little atoms. We know they exist. Some people are trying to say, well, they don't exist. We know it exists because it leaves a spot. It's just we don't know whether it's here or there, right? But if I take one of the beam away, then I would always see that spot. So we know it's a particle, the electron, an atom, or atom is a particle. But so there's a connection between this little particle and us. But how to define it is really difficult. So that's the interpretation. How do we do this relation? So I think that's beyond physics. It's metaphysics. So I'll leave you with that. Thank you for your patience.